Hello, Link341. Welcome to yet another lecture in a series of lecture for our phonetics course. This lecture is going to be on sonority, syllables, and stress. Without further ado, let's start. We ended up our last lesson with an interesting fact about vowels, right? Some vowels are louder than the others in terms of their decibels. For example, in a study by Fonagi in 1966, they found that relative to the vowel a, uh, is less loud or not that does not have the same intensity. It has minus 3.6 intensity in comparison to a. Yeah, that's a. That's a. That's O has minus 7.2, E has minus 9.7, and U has minus 12.3. And I asked you, why is that so? Why do you think that certain vowels are louder than others? Well, the simple fact is that is the openness of the mouth, to put it very simply. So the more you open your mouth, the more intense your vowels will be, or louder they will be, simply because a great amount of air can exit your mouth, right? And another factor involved besides openness is roundedness. For example, for O, O is less loud, of course, than A, which is in the middle of this vowel space spectrum. But you can see that U is even less loud than E, which are very high, and mouth are almost closed for these two vowels, because if you round the vowels, there is barely any space for air to get out, right? In U, so you are producing the least loud vowel in this respect. So these are the two simple articulatory parameters that we pay attention: openness and loudness, because openness, and roundedness, which influence the loudness of a vowel. Another interesting fact, and this is data from Swedish, from Ellert in 1964, a bit outdated study, but still, I guess, relevant, is that high vowels in comparison to low vowels will be shorter, right? So even long, because Swedish has long and short vowels, even long vowels will be shorter than high long vowels will be shorter than high low vowels. So, than low long vowels. But you get a pattern here, or you get the point. So or a, or this vowel here that we haven't talked about, are all longer in duration, and the reason is basically the same. So intuitively you understand, because you have to open your mouth more. It takes more time to close the mouth too, so it takes more time to get into this position of opening the mouth, in comparison to this neutral vowel such as schwa, e, u. These are intrinsically shorter, right, than or some mid vowels such as e or a or o, right? And yeah, here for Swedish, apparently this one is mid, which okay. Let's say it works that way in Swedish. So this is the reason, right? Intuitively is the same as with loudness, right? The length is also influenced by some intrinsic properties of vowels. just want to mention another important fact that, or another important property that vowels have, and that's frequency. They have some intrinsic pitch, which we will see in our next slide. But first things first, these are the two examples of the mystery tone language, or the just examples of words or vowels produced by this person. And this is a tone language. This tone is supposed to be the same for both, right? However, the right hand side is a little bit, shows a little bit higher F0 or fundamental frequency, and this is where they produce E, right, in comparison to A, and E has an intrinsically higher frequency. Let's hear it.
C, Ka.
But the tone is the same, right? I don't know, 5/5 or 5/4, whatever you like, but that's the tone that which is the same. The type of the tone is the same, while fundamental frequency is quite different, or not quite different, but slightly different. And that's because of the intrinsic F0 or fundamental frequency of certain vowels. So E will in general have the highest frequency, the highest F0. A will have lower, and A will have even lower frequency. A will have the lowest frequency. Now when we go up there to the mid, O will have a little bit higher frequency, and U will also have a very high frequency. So E and U are higher in their frequency. Now, why is this the case, right? And this works for both female and males. We just compare females E with females U, for example, or males E with males U, and we observe this relatively, similar data. There is something that there is an explanation, of course, for this. One dominant explanation or theory is what we call the tongue pool hypothesis by Honda, who devised this theory, or designed this theory in this explanation, whatever you like, call it whatever you like, in 2004. So I will try to walk you through this briefly. At the high end of the spine, you can see here the high end of the spine, basically your neck part, which goes towards the head, of course, there are larynx, right? And if you exert more tension to vocal cords, I think I showed you this in one of our lectures, where I wanted you to raise your glottis, so you would make a higher tone, like E. And if you do not exert so much tenseness on your vocal folds, you will make a lower sound, such as E, and you may, if you put your fingers here like this, feel how your glottis is raised. What this means is basically that you're raising your tongue for high vowels, and when you're raising your tongue, you're also raising the larynx, right? The cricoid cartilage rises up and around the spine, thus stretching the vocal folds here. So these are the vocal folds, and the cricoid cartilage is stretching those, not literally, but they are being stretched, right? They're being more tense, and that's how you produce high vowels and increase the longitudinal tension. This is just a term that we're using for this kind of tension, and if you want to know more about it, take advanced phonetics, of course. So you will produce a higher sound in comparison to the low sound when you are making e, and I'm not even trying to change anything, right, in just producing these vowels. So that's one explanation. And to summarize the properties of vowels, which we call intrinsic, which means that they are embedded within vowels, that's the nature of vowels, right? High vowels are less intense, they're shorter than low vowels, but they are higher, right? Low vowels are more intense, so they have greater intensity, they're louder, they're longer, but they're lower in pitch. And these three factors, intensity, duration, and F0, play a very important role in stress, right? In stress perception and production, in what we call prominence. So generally, I'd say the higher the F0 is, the longer, the more intensity there is. These are the indications, or these are the cues for stress. These are certain parameters that we follow when we want to determine, oh, here's the stress of a word, right? So greater intensity, longer vowels, longer stressed portions, and higher. Okay, all of these factor into the perceived stress. We've come to something that I wanted to talk about, or this brings me to sonority. Sonority is defined in different ways, but a course in phonetics books defines the sonority as loudness relative to that of other sounds with the same length, stress, and pitch. So all things being equal, all other things being equal, sonority of a sound is loudness relative to other sounds. And we know that some speech sounds are louder now than others, right? We've seen the intrinsic loudness scale here. So loudness is as well highly context dependent measure, just like we talked about tone, and when we talked about pitch accents, and even F0 or pitch, just pitch, not F0, but pitch rather, length or duration, all of these are context dependent. So we have to compare them to some other sounds or features. And compared to other sounds, and this is from Ladefoged's book, would be the most sonorous. So would be perceived as louder or loudest in comparison to other speech sounds. Ed, then ed, and id, and e, u, and so on and so forth. We come to liquids, then to nasals, then to voiced fricatives, then voiceless fricatives, and finally almost no sonority observed on the scale are stop consonants, right? So stop consonants, right? So we come to the sonority scale. A sonority scale shows that low vowels are the most sonorous. They have high sonority. High vowels are a bit less sonorous than glides, liquid, nasal, fricatives, and stops, which are the least sonorous of all speech sounds. And this is sonority operationalized if we want to figure out this, what's going on phonologically. Let me show you why. So this is an old, and how it relates to syllables. So why are we talking about sonority, right? Because we need to understand syllables in order to understand stress, ultimately. As I said, stress will be placed on certain syllables. Stress is a property of syllables, and some intrinsic vowels or some intrinsic properties of vowels will contribute to where stress is, or where you might hear stress as well. However, that's not all there is. Intensity, duration, and F0 of syllables is what matters, and sonority is very important for syllable structure. So this is an old idea from Pike, 1943, who said that syllables are organized around peaks in sonority. Now that we know that which syllables are more sonorous, or which speech sounds are more sonorous or less sonorous, we can say, well, there is some pattern there, right? And what kind of pattern is this? This is the sonority sequencing principle, as I said, developed by Pike, sort of a grandfather of structural linguistics. And the idea with the syllable is that it is going to have some sort of anchor or peak in the middle of it. For example, this will be the stop, right? And stop is low in sonority, like we showed here. This one will also be the stop, and it is very low in sonority. But in the middle of it, in the middle of this word, which is monosyllabic or has one syllable only, there is a low vowel, which is very high in sonority, bad. And this is a well-formed syllable in English. To fill in the blanks here, we can introduce L and N. L is a liquid, so it's more sonorous, right? Somewhere here, then stop, then nasals are more sonorous than stops as well, and we can fill in the blanks here. So we are rising up in sonority, right? We are going up to the peak of the sonority. L is more sonorous than B, and R or A is more sonorous than O and B, right? The same goes with N and D. So these are blend works well too, right? These are very well formed examples of a monosyllabic word, or this is a well formed example of a monosyllabic word. What some technical terms that we want to introduce to you are sonority peak. So we call this vowel sonority peak, or nucleus. The sonority peak is the nucleus of the syllable, right? Then the first two sounds are called onset or onset. So this whole thing is an onset. And the last two sounds are called coda, right? They follow the nucleus, coda follows the nucleus, and onset precedes the nucleus. And lastly, the nucleus plus coda make a rhyme. And this is important for some phonological reasons, which we won't get into right now. The idea is that onsets must rise in sonority towards the syllable peak, right? As we said, if you take a look at B is least sonorous, L is more sonorous, and then it's rising, right, in the level of sonority. Oops. And some examples here are play, quick, fling, thwack, and so on and so forth. So for example, quick, right, would be something like this, where this would be onset, right? K is a stop, W is a glide, so we get more sonorous consonant here. For fling and thwack as well. Slide, snow, sweet are also such examples, although S is a very special case. S breaks the patterns all over the place, and with S we have problems, so to say, because you might have a word such as Steve, right? It's a fricative than a stop, which is not the best combination with respect to sonority. So sonority does not always work, and we'll see why. But in 90% of the time it does. What onset clusters should be ruled out? Well, as an easy example, I'd say we may switch these, for example, and maybe with quick, yeah, we cannot say that, or maybe lefing, no, not really. Thwack as well, pay, those are excluded. We cannot have those clusters because they do not follow the sonority sequencing principle, right? Can you think of any English examples where this principle might not work? We just said what might be the case, and we said that S is a special case. I'll just say that about it. The codas also must drop in sonority away from the syllable peak. So high sonority, right? Then the syllable, then the sonority, falls or goes down, right? All right. Okay, so let's see some examples in English. Some examples are fricatives, fricative plus stop sequences. For example, 10th, hand, help, helm, heart, test. Yeah, so all of these are well formed according to the sonority principle. What coda cluster should be ruled out? Well, you can think of maybe 10th, right? Tethen, yeah, very difficult. Hand, hadden, not really good. We don't have words in English with those. Heart, hutter, maybe not very well. Helm as well. Hamel, yeah. So most of English words do follow these. Even ts, even for example, test would be tats, which is not a well-formed word in English. Okay, so as I said, sonority sequencing principle works 90% of the time, but it doesn't always work, and we mentioned some violations to this principle. I didn't want to mention more. However, there are more violations and exclusions, but the problem is in defining a syllable, right? How can we define a syllable? What is a syllable? We cannot just say, well, it's sounds blended together. That's okay, I mean, phonologically, but phonetically, what works? What's a syllable? Why do we need it at all? Well, there was an idea, phonetic idea, of course, that each syllable is a chest pulse. However, it turns out that did not work. There was an idea that we squeeze our chest every time we are producing a stressed syllable or peak, right? Or maybe not just stressed syllable, but a peak in a syllable, right? Which something that really doesn't work. And Ladefoged proved this. Said, well, chest muscles don't necessarily contrast for each syllable. That would be too much, right? And are there any better ideas, right? If you have any better ideas, let us know. You would help out linguistics and phonetic science a lot, because we are relying for now on phonological explanations of syllables. And syllable, it is quite a property of phonology. Check out the following words. These are examples from Linguistics 201, or something that you can encounter in 201. And those are quite difficult for students usually, but let's break them apart, right? So you have 6 words here: Atlantic, America, astronomy, atrocious, arcade, arthritic. What happens here, right? So we may want to bring up the IPA now at this point. I'll just copy these, for example. Yeah, so Atlantic, oops, change my keyboard. So Atlantic, I have it here as a flap. Maybe it's a nasal flap. It should be a nasal flap for sure. So like this, Atlantic, right? Or Atlantic if you want a full pronunciation of the word, is transcribed like that. Then we have America. I'll just copy, not to lose any time. America. Then we have astronomy. Astronomy and atrocious, difficult word to produce. Okay. Arcade, right? I'll copy both of these. Arcade and arthritic. Sorry for the mess. Right, and arthritic. Okay, should work. Yeah. Right, so what we notice here is that I'll do it like this, is that all of these start with A, right? In orthography, A. And all of these, and with all of these, the stress is on the second syllable, right? Second syllable. However, only 3 of these, America, astronomy, atrocious, start with a schwa, right? Start with a schwa. And you may have noticed when you're producing Atlantic and atrocious that, or yeah, Atlantic and atrocious, that T's are not the same. Why is that so, right? Why is that the case? Well, simply because these are syllables. This is one syllable, this is another syllable, right? And these R's in arcade, arthritic, are followed by codas, right? They're followed by codas here as well. This means that the T will be different. It's a coda T, and it's not a T that is being stressed, right? This R is not stressed. It's K'd, right? This R is also not stressed. It's thritic or 3, right? In this case. So we see that there is some difference, right? And this difference is in the syllables, right? It's a syllabic difference. The reason why I'm talking to you about this is because we would not be able to explain what happens in this case if there was no way of talking about syllables. This is where phonology helps. And there is no rule to pinpoint where certain sounds can occur without inferring this from a pattern, right? So there is a pattern here. All the words that start with a schwa, right? They are its own syllable, and they precede the stressed syllable. But all the other words that do not start with schwa have a coda consonant, right? They also precede the stressed syllable, but they have a coda consonant, and this coda consonant is different from what we could see in a stressed consonant. Atrocious, Atlantic, right? Here even we can have a glottal stop, maybe something like this, as our consonant over here. So without the syllable, without the notion of a syllable, we wouldn't be able to say, well, that's what happens, right? Why is T on this side? Why is it not stressed? Well, because of the notion of a syllable, and because till do not follow the sonority sequencing patterning, right? We don't have syllables that start with till, but we have syllables that start with ter, ter, right? We have syllables, we don't have syllables that start with erk, right? So erk, no words in English that start like this. No words in English that start with like this, right? So we don't have these, and that's why the notion of a syllable, concept of a syllable, is very important. All right, hopefully this is clear. And now I would like just to go through some of the definitions of a syllable. So in your text, or Ladderforget defines, not in your text, but Ladderforget defines syllables as necessary units in the organization and production of utterances. The construct of a syllable can account for a variety of interesting phonological patterns, and that's where they help. For example, vowel reduction in unstressed syllables in English, like here, we don't have full vowels. We don't have atrocious. We have atrocious, right? So because there is what we call a vowel reduction, vowel reduces to a neutral form, before a stressed syllable. And that happens all the time, like contrast, which we will see later. Fricatives and stops, the voice at the end of a syllables in German and Russian, for example. So that's how we decide, okay, this is the end of a syllable, they devoice. From the, they become t. In rad, they don't say rad, they say rat, right? In German, or rad, right? Much better. Place contrasts disappear in coda position in Japanese and many other languages. Right, that also happens. So place contrast is, for example, both become alveolar or velar at the end of the words, or in coda positions, right? So we know now that syllables are influencing this. And voices stops are aspirated at the onset of stressed syllables in many Germanic languages, in English too, right? Maybe here even t can be stressed, Atlantic, right? Oh, sorry, atrocious, right? Atrocious. So voices stops are aspirated at the onset of stressed syllables in many languages. And now finally we do understand why or when aspiration happens. Right. Now, when we know what a syllable is, we can say, well, stress is a suprasegmental property that applies to the whole syllable, right? Or to whole syllables. And that's clear, right? So stress is a property that applies to the whole thing. So atrocious, maybe here you would have it, right? Atrocious, this is a stress syllable, and stress applies to it. So it's superimposed upon that part. And syllables that are higher in pitch are stressed. Syllables that are longer are stressed usually. Syllables that are louder are usually stressed. And stressed syllables reflect more phonetic effort, which we will see later. But the combination of these factors gives stressed syllables more prominence than unstressed syllables. So you kind of perceive them as more emphasized. That's what it means, more prominent, right? Or more prominence. And that's what stress depends on. Now we know what the frequency is, F0, right? In acoustic terms, or fundamental frequency. We know what the length is now, right? We know, we talked about quantity in certain languages, and we know that length is very important in those languages and in English as well for stress, right? We now know what intensity is. We talked about intensity, so we know how to talk about it. And all of these were introduced to you with the aim of introducing to you or describing to you stress. So stress syllables are a combination of these. I believe, and from what I could see in English, pitch is the most important parameter of stress, but it does not always have to be the case, right? That's why it's so relative. And when we talk about pitch or F0, right? This is the word insult.
Insult.
Sorry, insult.
Insult.
My bad. And this is the word insult.
Insult.
Right?
Insult.
Where the pitch is quite higher on this first syllable, right? While here the pitch is higher on the second syllable. Salt, right?
Insult. Insult.
Right. Pitch tends to drift downwards at the end of the utterances, so pay attention to that. So if I say, oh, I'm getting a lot of insults, pitch would drift down anyways because of the intonation, or overall intonation. So when we are producing these words individually, it's easier to understand, but in a sentence, it's much more complex. When it comes to intensity, perceptual stress is highly correlated with the area under the intensity curve. So, for example, contrast.
Contrast.
And contrast.
Contrast.
Right. So this is the first and stress syllable, and you see that the intensity here, the first syllable is highest, right? This whole area is quite intense, and here the second syllable is more intense, right? And we can give this a shot maybe in prod, right? Let's try to record it while we can. Contrast, contrast. Maybe I emphasize the first word too much. Okay. So what I have here is I'll just set the pitch settings. Okay, standards are these. I'll just intensity settings. All right, good. So when we want to show intensity, we just go to show intensity, right? So here, show intensity, and this intensity trace appears, right? And you can see the first word, contrast. There is a whole bunch of, there's a huge intensity. As I said, I emphasize it too much, but a huge intensity right here at around 74 decibels. And here you can see the contrast intensity is on the second syllable. It is the intensity is higher on the second syllable, right? That's what we want to determine. Which syllable has higher intensity? And now we know. All right. So we've done that little our little experiment. Now we can move on to phonetic effort. As I said, there is a general phonetic effort that is included or incorporated in producing stressed syllables. For example, voiceless stops are more aspirated at the onset of stressed syllables in English. Vowels are often reduced to schwa in unstressed syllables. And we have certain phonetic effort that leads to or causes these to be the case, right? So we want to say tank, right? We are stressing this syllable, there is a little bit of air coming out of our mouth, and we get aspirated stops. When we are not stressing the syllables, we get schwa, right? Usually, okay? And there was a study by De Jong, I think he was Steve's colleague, who used X-ray microbeams. In this study, the target was the T on put. So this was the target. How the T differs when it's not stressed and when it's stressed. So the experimenter placed these little pellets on people's tongue and saw or observed how they produced these two sentences. I said, put the toast on the table, not the napkins. I said, put the toast on the table, not the napkins. And that's where the emphasis lies in the second sentence. In the first sentence, it lies on toast. What we received from that are two different patterns. When there is when the sound was not stressed, we received the pattern, like merging into this dental here, right? But when it was stressed, we received a more alveolar alveolar movement, right, towards the alveolar ridge, and it did not merge into this following dental or interdental fricative, right? Put the toast on the table. I said put the toast on the table, right? As non-native English speaker, maybe it might be more difficult for me, but you can definitely produce it more naturally, and you might even feel the difference, right? So that's what the study generally observed. And lastly, I just have to say that there are varying levels of stress prominence. I've seen some of you using the what we call secondary stress. Please, or you don't have to use it. So you don't have to use it in your transcription. Stay away from it because it's a little bit tricky and it's not always present in words in English. Generally, we have, for example, the breakdown here. At each of these has a vowel, right? So we put an X if it has a vowel, right? So each of these syllables has a vowel, right? Now, where is the full vowel? Well, the last one does not have a full vowel, right? So we put X's here. And the stress is usually on a full vowel, right? When we have vowels, so it can either be on the first one or on the third one, because there's where the greater pitch is, the loudness is. These are longer sequences, and now we have exploitation, right? We have to decide which one is primary. Well, we decided that based on more prominence, and we determined that the more prominent vowel syllable is this one, tation, right? And that's where the primary stress lies. If you want to denote the secondary stress, you may use this this diacritic here, which is kind of a subscript, but you don't have to do that. So this is just me telling you, well, English is complex. On longer words, you might have secondary stress, such as exploitation, pronunciation, stuff like that, and longer words like that. However, pay attention or focus on just a single syllable that is in general higher in pitch, longer, and louder, right? That's how we determine stress. And I know you've been asking about it this whole term, but that's why I said it's complex. We have to first know what F0 is, fundamental frequency or frequency in general, what pitch is, how it's related to fundamental frequency, what intensity is, what duration is. So all of these together can explain where stress is. And we also learned what the syllable is today, hopefully. That's all from me now. See you very, very soon, and take care.